good day viewers. In this tutorial, I will let you know how to find the eigenvalues and what? And eigenvectors. Eigenvectors, it deals with what? With only vectors without no scalars. Like the eigenvalues a minus what? Minus lambda I, it will be equals to 0. This I, it is indicating what? The identity matrix. But the eigenvalues, okay, the eigenvectors are what? Are vectors that has a spatial relationship with what? With matrix. Let's say a minus what? Lambda I multiplied by what? By the x scalar, and it will be equals to 0. So therefore, this is the matrix. This is 2 by 2 matrix. Let's say we are asked to find the eigenvalues and what the eigenvectors. So how can we find eigenvalues and how can we find the eigenvectors? So let's see what we are going to do. So the general formula, or let me say the general equation that you can be familiar with it in what? To find it easy way on finding what? The eigenvalues. We have to use this relation that say that a minus what? Minus lambda I, it will be equals to what? It will be equals to 0. It means the value of a, the matrix A, 1, 4, 1, and 1, minus what? Minus the lambda. This is lambda multiplied by what? By the identity matrix. What is identity matrix of 2 by 2 matrix? The identity matrix of 2 by 2 matrix is 1, 0, and what? And 1. And then it will be equals to what? It will be equals to 0. So the next thing that we are going to do is that if I say 1, 1, 4, and 1, this 2 by 2 matrix minus what? If I say lambda multiplied by 1, I will end up with what? Lambda 0, 0, and what? And lambda. Why? Why? Because if I multiply both sides by what? By each of the element that is inside this matrix, it will give me 0, it will give me 0, it will give me lambda, it will give me lambda. And after this, it will be equals to 0. So if I minus this A, this matrix A with what? With this lambda I will end up with what? So therefore, it will be equals to 1 minus lambda, 1 minus what? Lambda 1 minus 0, it is what? The same thing as 1. 4 minus 0 is the same thing as 4. 1 minus what? 1 minus lambda, it will be equals to 0. So I have to find the determinant of what? Determinant of this matrix. So how can I find the determinant of this matrix? If I say lambda 1 minus lambda multiplied by what? 1 minus lambda minus what? Minus 4 multiplied by 1. So this is how you can find the determinant of what? 2 by 2 matrix. So therefore, let me see. So if I say 1 multiplied by 1, I will end up with what? This it equals to 0. 1 multiplied by 1, which is what? 1, and therefore what? 1 multiplied by negative lambda, it will be equals to what? Minus lambda. And lambda multiplied by 1, it will give you the same thing, minus what? Minus lambda. Minus lambda multiplied by minus lambda, you will end up with what? With what? With positive lambda squared plus lambda squared, and therefore minus what? 4 times 1, which is what? 4, it will be equals to. So this is what it is going to turn to what? To quadratic equation. After turning to quadratic equation, then you will find the value of what? X. So in this, we have to find the value of the 2 lambda. So if we find the value of the 2 lambda, that is what? The eigenvalues. And then we are going to use that values to find what? The corresponding eigenvectors. So therefore, if I say 1 minus 4, it will give me what? 3. Sorry, plus 1 minus what? 4 is the same thing as 1 minus 4. It will give me minus what? Minus 3. But before then, I have to take this lambda square because it is positive. Minus lambda, it will give me what? Minus 2 lambda, and therefore minus 3 it will be equals to 0. So therefore, I have to find the value of what? Of lambda 1 and lambda 2 in this quadratic equation, because this is turned to quadratic equation. So what number should I going to multiply it to give me 6, and therefore if I add it to give me -2? Let me say that what are the factor of 3? Factor of 3, 1 is there, and therefore the 3 is there. 1 is there, and therefore what? 3 is there. So what number should I going to use? If I say 1 minus 3, 1 minus 3, it will give me what? Plus 1 minus 3, it will give me -2. Yes. So if I say plus 1 multiplied by what? -3. Yeah. Still, it will give me what? Value of -3. So therefore, let me say that lambda squared plus what? Plus lambda, which is 1. So therefore, minus what? Minus 3 lambda minus what? Minus 3, it will be equals to what? 0. So therefore, lambda into what? Lambda into what? Lambda, and therefore plus what? Plus 1 minus what? 3 into what? Lambda. Lambda plus what? Plus 1, it will be equals to 0. Yes, you all know quadratic equation. If you need more on quadratic equation, get back to my videos or check the description of this video. You will see how to what? How to find the quadratic equation by factorization method. Because I just factor out what? I factor out this, I factor out what? This. How did I factor it? If I'm going to factor it, I will have lambda into lambda plus what? 1. Because lambda times lambda, it will give me lambda square. Lambda times 1, it will give me plus lambda. It automatically turns to this. And therefore also 3 multiplied by what? Lambda, it will, okay, 3 plus 1. Minus 3, it will give me what? Minus 3 lambda. And therefore this multiplied by it will give me minus 3. It automatically turns to this. So this is how I get these values. So therefore, I have to fix lambda plus 1, and therefore lambda minus 3, it will be equals to 0. So therefore, lambda plus 1, it is equals to 0. It automatically equals to lambda, it will be equals to -1, because 1 will cross the equal sign, it will become negative. And therefore, lambda minus 3, it will be equals to 0. And therefore, if the -3 crosses the equal sign, it will become positive sign. So therefore, what? Lambda, it is equals to what? 3. Positive 3. So therefore, as usual, lambda 1, it will be what? -1. And lambda 2, sorry, maybe you cannot see. Lambda 1, it is equals to -1. And lambda 2, it will be equals to it will be equals to positive what? Positive 3. So therefore, this is what? This is called the eigen what? It will call the eigenvalues. So these are the eigenvalues. So let us see the eigenvectors. We are going to use these eigenvalues to find what? The corresponding eigenvectors. So lambda 1, it will be equals to 3, or lambda 2, it is equals to -1. You can put either lambda 1 to be what? -1, or lambda 2 to be your -3. So if I am going to find the value of eigenvector, I've already tell you that in eigenvector A minus lambda I multiplied by what? By the scalar value. Because we are needing to find what? The scalar, which is x. Okay, sorry, yes. Yes, yeah. And it will be equals to what? 0. So what the value of what? A? The value of A, this is this matrix, 1, 1, 4, 1. So what is the value minus lambda? We are going to substitute the value of lambda. We have to put lambda 1, which is 3, and then we are going to substitute for -1. But let's start with 3. So therefore, I will end up with 3, 0, 0, and 3. I hope you get it. I'm just going straight forward. Let me show you. 3 multiplied by what? 1, 0, 0, and 1. 3 multiplied, here it will give you 3, 3, 0, 0, and 3. This is what I do. So therefore it will be equals to, okay, multiplied by what? Multiplied by x1 and what? X2, it will be equals to what? It will be equals to 0. So therefore I have to minus this. If I say 1 minus 3, I will get negative 2. 1 minus 0, I will get 1. 4 minus 0, I will get 4. And therefore 1 minus 3, I will get what? I will get negative what? 1 minus 3, I will get negative 2. So therefore, I have x1 and what? X2 and then what? 0 and 0. So therefore, if you check to my video, there is a video that I make with reduced row echelon form, and therefore the row echelon form, which are the Gauss-Jordan and Gaussian elimination. So therefore, we have to use the reduced row echelon form here because we have to make these numbers to be 0. So how can I make them to be 0? So therefore, to make this to be 0, minus 2, 1, 4, and minus 2, if I say that row 2 plus 2 row 1, where is row 2? This is row 2, which is the same thing as 4 plus 2 multiplied by what? Row 1. This is row 1, which is negative 2. This is 4 plus 2 multiplied by this, which is negative 4. Wow, it gave me 0. So what of the second row? If I say that row 2, where is row 2? Row 2, yeah, row 2 is negative 2 plus 2 row 1. 2 multiplied by row 1 minus 2 plus what? Plus negative what? Sorry, row 1, it is positive 1. It will give me 2. Wow, it's the same thing as 0. So therefore, this is make it easy. So you have to take note that in some of the way that if you are going to find the eigenvectors, you must use the reduced row echelon form. So therefore, this will be minus 2, 1, and then 0, 0 of what? Of x1, x2, it will be equals to 0 and what? 0. So therefore, if minus 2 multiplied by what? Minus 2, it will give me minus 2x1, and minus 2 multiplied by minus what? Okay, sorry, 1 multiplied by x2, it will give me plus x2, it will be equals to 0. I have to get it. This multiplied by this, and this multiplied by this. So therefore, let x2, it will be equals to what? If negative 2x1 cross the equal sign, it will become what? 2x1. Yes. So the next thing that I'm going to do, I have to choose. Let me choose x1 to be equals to 1. Why? Because I have to lead x2 to be 2. So if x1 is equals to 1, so therefore x2 it will be 2xy. Instead of x1, I put 1. So therefore the x2 it will be equals to what? Positive 2. So at the end, the value of x it will be equals to x1, I have 1, and x2 I have what? The value of what? 2. It means what? The value of this lambda 1, I get what? I get this. So therefore this is for what? If lambda it is equals to 3. So let's see if lambda it is equals to what? It is equals to negative 1. So therefore the value of the x, okay, sorry, lambda x, so therefore of the value of lambda 3 of x, it will be equals to what? 1 and what? And 2. So therefore, if I'm going to check for the lambda, it is equals to 1. We know that the a minus what? Lambda I of x, it will be equals to 0. What is the value of a, which is 1, 4, 1, and 1? Minus what? Minus, yes, it is minus 1. Because the value of this lambda, I have to substitute the lambda with what? With minus 1, which is negative 1. So therefore, I will end up with negative 1, 0, 0, and what? and -1. So as what? X1 and x2, it will be equals to what? 0 to 0. So therefore, if I say 1 minus minus 1, 1 minus minus 1, it will be equals to 2. And therefore 1 minus minus 0, it will be 1. And therefore, if I say 4 minus 0, it will give me what? 4. And 1 minus minus 1, it will give me what? It will give me 2. So therefore, this is 2. So therefore, of what? X1 and x2, it will be equals to 0 to what? 0. So the next thing that I'm going to do is that I have to still use the reduced row echelon form to make this 4 and 2 to be 0. So therefore, the 2, 4, 1 and 2 in row 2, I have to say row 2 minus 2 row 1. If I say row 2, where is row 2? Row 2, it is what? 4. Row 2, it is 4, and therefore minus 2 multiplied by what? Row 1. Row 1, which is 2. Therefore, 4 minus 4. Yes, it is 0. We get it right. So therefore, 0. Okay, sorry. The first 0. And this will keep it the way it is, which is 1. So let's check for this. Row 2, which is 2, minus 2. Row 1. Row 1, which is 1 multiplied by 1. 2 minus 2, yes, minus 2, which is 0. So therefore, we want the 0. So therefore, we keep up the 0. So therefore, multiplied by what? X1, x2, which is b equals to 0, 0. So therefore, I have to multiply 2 by what? X1, 2x1, 1 by what? 2 plus what? Plus x2, which will be equals to 0. Because there is no way to multiply with these zeros between this and this. So therefore, I have to keep x2, it will be equals to, if the positive 2 cross the equal sign, it will become negative. So therefore, negative 2x1. Yeah. So here I have to also choose x1 to be 1. X1, it will be equals to 1. So therefore, x2, it will be equals to minus 2 multiply x1, we choose it as 1 multiplied by 1. So therefore, x2, it will be equals to negative 2. And therefore, our x1, we choose it to be 1. So therefore, the x for lambda 2, it is equals to negative 1. It will be equals to what? 1 and minus 2. So this is all I have for you for the finding of eigenvalues corresponding to eigenvectors of 2 by 2 matrix. Please do share to your learning colleagues to know more about eigenvalues corresponding to eigenvectors. Don't forget to press the bell icon so that you will be notified immediately if I uploaded a new content. Thank you for watching. Don't forget to comment and like. Thank you.